Welcome, Dr. Sampak College of Business students, and really all you future business bros out there, to Managing the Future, the MIS podcast. Today, we're doing a really important deep dive. We're tackling a field that's, well, it's not just growing, it's fundamentally changing everything. Data analytics. Our goal here is to unpack the key stuff for you from Module 03 of your textbook, Connect Master Management Information Systems. That's the one by Richard Tedmon and Casey Wilhelm, McGraw Hill, 2024. And look, this isn't just about learning definitions. It's about giving you that strategic edge, understanding how data is really driving modern business. So let's get into it. Oh, and while you're listening, please do remember to like, subscribe, follow, share it around, leave a comment. It really helps us make this a better resource for everyone.
Yeah, data analytics is definitely right at the forefront. Business, IT, you name it. It's a really dynamic space, especially if you've got that curiosity, and an interest in tech, and crucially, that ability to interpret what the data is telling you. And what's interesting is businesses aren't just like playing around with it anymore. They're investing seriously. They want data-driven cultures, and that means they need people who really get it.
Okay, so let's strip it down then. At its heart, what is data analytics, and how do we even, start to categorize it? It seems so broad.
Right. So at its core, it's the process. It's investigating raw data. The goal, to find trends, correlations, stuff that isn't obvious right away. It's really about turning all that noise, all that information into actual insights you can use. And yeah, we usually break it down to the three main types. They kind of build on each other, giving you deeper understanding as you go.
Okay, a progression. I like that. So what's step one on that ladder? How do we first start making sense of data with analytics?
Step one is descriptive analytics. Think of this as your rear view mirror. It answers the question, what happened? You're summarizing past data to understand why something occurred, like looking at last quarter's sales. Which products did well? Why did customer churn go up here? It helps you spot problems or successes that have already taken place.
Understanding the past, okay, that's fundamental. But if you're running a business, you need to look forward too, right? That can't be the whole story.
Exactly. Spot on. Once you know what happened, you want to know what will happen. And that brings us to predictive analytics. This is less rear view mirror, more looking through the windshield. It uses those historical patterns to forecast future events, to anticipate possibilities. Classic example, predicting customer behavior. Who's likely to leave in the next few months? Or what's the demand for this new product can be?
Right, predicting. And then I guess the ultimate step is knowing what you should do about those predictions. Is that where prescriptive analytics comes in?
Absolutely. Yeah. Prescriptive analytics. That's the top tier, the most advanced and arguably the most powerful. Think of it like a really smart GPS. It doesn't just show your route. It suggests the best route, dodging traffic, considering everything. It aims to determine the best course of action, not just what might happen, but when and why, and then it recommends what to do. Imagine like a logistics company optimizing delivery routes in real time, using live traffic, weather. That's prescriptive. It's about driving action.
That's incredibly powerful. I mean, for you listening as future business leaders, this isn't just about slightly better decisions. It's proactive, predictive. You can anticipate market shifts, customer needs, things you couldn't even imagine doing 10 years ago. So beyond decision-making, what other ways does analytics show up? Why is it so essential?
Oh, it's everywhere, seriously. Better decision-making, yes, but also huge improvements in customer service. You can anticipate needs, personalize things. Then there's efficiency in production. Operations, finding bottlenecks on the factory floor, optimizing supply chains, reducing waste, even healthcare. Yeah. It's changing patient experiences, speeding up R&D for pharmaceuticals by analyzing massive trial data. It's all about improvement through insights.
And what about the big picture trends? Where's this field heading right now?
We're seeing definitely a big jump in investment. Companies are pouring money into analytics, but they also want a clearer ROI. A return on that investment. There's also rapid growth in companies that provide data models and services because not everyone can build it in-house. We're also seeing more data product development, insights getting baked right into apps or internal tools. And interestingly, the role of the data scientist is getting more specialized. Generalists are less in demand than people with deep niche expertise.
Okay, so all this work needs a solid foundation. You mentioned infrastructure. Can you explain this idea of a data ecosystem? What is that exactly?
Yeah, the data ecosystem, it's basically the whole IT setup.
Yeah.
The architecture, the software, the programming languages, the storage, everything working together. It's the environment that lets an organization collect, store, analyze, and interpret data effectively. It's where the data lives, essentially.
And data doesn't just sit there, right? It goes through a process. You mentioned a data project lifecycle. Can you walk us through those steps? Seems important.
Absolutely. It's a pretty logical flow, usually 5 steps. 1, sensing. This is key.
Yeah.
Identify what meaningful data you actually need to collect for your problem. Not all data is useful. 2, collection. Gathering that data, but making sure it's from validated, reliable sources. Quality in, quality out. 3, wrangling, also called data cleaning or prep. This often takes the most time. Converting that raw, messy data into something clean, consistent, usable for analysis. Like prepping ingredients before cooking. 4, analysis. Now you actually examine the clean data. Look for patterns, trends, apply those descriptive, predictive, prescriptive methods. This is where the insights happen. 5, storage. Finally, you securely store and maintain the data so it's accessible for future use. Good storage is crucial for integrity and making decisions later.
That paints a really clear picture of the what and why. Let's shift gears a bit to the who. What does it actually take to be a good data analyst? It sounds like you need technical chops and other skills too.
You're absolutely right. It's definitely a blend. It's not just about crunching numbers. You need strong skills in observation, research, interpreting complex stuff. Google actually highlights 5 key analytical thinking skills here that I think are spot on. Curiosity, always asking why. Understanding context, seeing the big picture. A technical mindset, thinking logically, step by step. Data design, knowing how to structure data well. And data strategy planning, how data helps achieve business goals.
So beyond that way of thinking, what's the day-to-day look like? What does an analyst do all day?
It can be pretty varied, honestly. They spend time extracting data, definitely, building reports to show findings, monitoring KPIs, key performance indicators to see if things are working, identifying trends, obviously, but also collaborating a lot with managers, executives, other departments to make sure the analysis actually helps the business. And a big one, using data visualization tools to make their findings clear and persuasive, plus structuring those huge data sets so they're actually usable.
That's quite a list. What about the specific tools and technical skills? If you're a student listening, what should you focus on learning?
Okay, technically, strong technical writing is important for documenting everything. You definitely need experience with computer code. SQL is fundamental for databases. Python is huge for analysis and machine learning. Knowing systems like Oracle helps too. Obviously, strong analytical and problem-solving skills, that's a given. Then there's data visualization software, Tableau, Power BI are the big ones. You absolutely need to know Excel inside and out and just general spreadsheet best practices. And don't forget the soft skills. Good time management, handling multiple tasks, multitasking, hitting deadlines, and really strong oral communication. You've got to explain complex data simply.
Okay, so given all that, how does an analyst know if a project was successful? It sounds like it's more than just handing over a report.
Oh, absolutely. Success isn't just a report. It's about blending the data, the facts, with a real understanding of the organization. They're constantly asking, what outcome do we need here? Who's this analysis actually for? What question are we really trying to answer? And realistically, what are the time constraints? Answering those ensures the analysis isn't just accurate, but it's actionable. It's relevant to the business goals.
This really leads into something crucial for everyone listening: data-driven decision-making, DDDM. This sounds like the ultimate goal of all this data work.
Exactly. Data-driven decision-making, or DDDM. It's about using facts, metrics, actual data, not just gut feeling, to guide those big strategic business decisions. Decisions that align with the company's goals. It's moving from intuition to evidence. Now, here's the interesting part from your textbook. Nearly 99% of executives say they want a data-driven culture, but only around 32% feel they've actually succeeded. That gap. It shows how valuable this is, but also how challenging it can be to truly embed data into the core strategy.
Right, bridging that gap is key for our listeners' future careers. So what's the process? How do you actually do data-driven decision-making? Is there a roadmap?
There is. It's a pretty clear 6-step process. It helps ensure data leads to real action. Step 1, ask. First, define the problem clearly. What question needs answering? Clarity here is vital. Step 2, prepare. Then, collect the data you need. Store it securely. Organize it. Get your foundation right. Step 3, process. This is the cleaning part. Check data quality. You need reliable data. Otherwise, garbage in, garbage out. Step 4, analysis. Now you dig in. Find the patterns, the trends, the relationships. Generate those insights. Step 5, share. This is crucial. Share what you found with the people who need to know, the stakeholders, often using those visualizations we talked about to make it clear. Step 6, act. Finally, based on everything, make the decision, take action. The goal isn't just analysis, it's driving change.
That's a great framework. Ask, prepare, process, analyze, share, act. Okay, let's talk tools. You mentioned 3 main types earlier.
Yep. The big 3 are spreadsheets, then databases and their query languages, and finally, data visualization tools. Each has its place.
Most of us know spreadsheets like Excel. How are they different from databases? What's the key thing a business student needs to grasp there?
Okay, good question. They both store info, right? Software and hardware, that's the similarity. But they're built differently and used differently, especially in business. Spreadsheets, think rows and columns. Data in cells. Entry is often manual, pretty flexible, good for quick, smaller tasks. Historically, single user, though cloud helps, databases. They're more structured. Use rules, relationships, managed by a database management system, DBMS. Data is in fields, records, tables. Entry is often automated, more controlled for data quality. And the big difference for business. Databases handle way more data, more complex data, and lots of users at the same time. Much more robust and scalable.
That scalability difference is huge. And to talk to these databases, we hear SQL all the time. What exactly is SQL? Why is it so universal?
SQL. Structured query language. Yeah, it really is the common language for databases. Think of it as how you ask questions of your data. Very precise questions, even to massive data sets. That lets you query, filter, track data, getting exactly what you need to inform strategy.
And the basics of writing SQL, what are the core commands students should recognize?
Right, the syntax, the rules of the language, the three you'll see constantly are select, from, and where. Select is where you pick the columns, the specific pieces of data you want back. From tells SQL which table or tables contain that data, and where is your filter that lets you narrow things down, like where city to Dallas or where sales 500.
So if I wanted to find, say, all the customers in Texas who spent over $1,000 last quarter, how would those work together? And how do analysts leave notes in their code?
Okay, so you'd select maybe customer name and purchase amount. From the customer table and sales table, probably joined together. And then where state, Texas's and purchase date is in the last quarter and the amount 1,000. See how you combine conditions. And for notes, you use 2 dashes. Anything after that on the line is a comment. SQL ignores it, but it's super helpful for explaining your logic to others, or even yourself later on.
SQL sounds powerful. Are there any downsides people should be aware of?
Like any tool, sure. It works really well with other languages. It's relatively easy to learn the basics. It's reliable, fast for querying. Those are big pluses. But some enterprise versions can get expensive. Managing complex databases can be tricky. And a key thing, SQL is primarily for relational databases, structured data. If you're dealing with lots of unstructured data like social media feeds or need super flexible real-time changes, you might look at NoSQL databases. They're designed differently.
Okay, so we get the data out, we analyze it, but then we need people to understand it. That's where data visualization comes in, right? Why is it so important?
Exactly. Data visualization. It's graphically representing data so people can easily see the results, the conclusions from your analysis. It turns complex numbers into pictures, essentially. And it's vital because, well, humans are visual creatures. We grasp visual patterns way faster than lists of numbers. It makes insights stick.
Is there a process for creating good visualizations, more than just picking a chart?
Oh, definitely. A good approach is 3 steps. 1, explore the data first. Really understand what patterns are there. What's the story? 2, plan your visuals. Based on the story and who you're talking to, what type of visual will work best? 3, create the visuals. Build them carefully. Focus on clarity and accuracy.
We've all seen bad charts, though. Graphs that seem designed to confuse or mislead. What are common mistakes people make? How can our listeners avoid them?
Yeah, that's a really important ethical point, too. Common pitfalls. Truncated graphs where the y-axis doesn't start at 0. Makes small differences look huge. Exaggerated scaling can do the same thing. Using too many variables or too much cluttered chart junk makes it impossible to read. And the most dangerous, cherry-picking data. Only showing data that supports your point and hiding the rest. Integrity is key.
So how do we make sure our visuals are honest and effective?
Best practices help a lot. Always define the purpose. What's the one key message? Design for your audience. What do they need to know? Include all relevant data for that message. Don't hide things. Format carefully clear labels, good fonts, and use color wisely to highlight, not confuse.
What are some of the go-to chart types in business? When would you use each one?
Some common ones you'll see a lot. Line charts. Great for showing trends over time. Think stock prices, monthly sales. Scatter plots. Good for showing relationships between 2 numerical things, like does more advertising lead to more sales? Bar charts. Excellent for comparing categories or discrete items. Sales per region. Performance by product line. Vertical or horizontal. Pie charts. Best for showing parts of a whole. Market share is a classic example, how different pieces make up the total.
Okay, and the tools to make these. Tableau and Microsoft Power BI seem to be everywhere. How do they compare for students looking to learn?
Both are industry leaders, really powerful. Tableau is known for being very strong in data prep, exploring data, creating really interactive, visually appealing dashboards. Great for what-if analysis, it handles huge data sets well. Downsides. Dashboards can sometimes look weird on different screen sizes. It doesn't natively support Python or R for really custom stuff, no auto-refresh for live data, and the price could be steep. Microsoft Power BI. Also great for processing and visualizing. Connects to tons of data sources, cloud or on-premise. Good data prep and modeling. Secure sharing. Benefits. That connectivity is huge. Security is strong. Pricing is often more flexible, especially if you're already using Microsoft products. Downsides. Some find the learning curve a bit steeper. It's not really for Mac or Linux users. The free desktop version has limits, and maybe slightly less language support than some others.
Wow. The sheer amount of data being created every day is just mind-boggling. But with so much out there, how do we pick the right data? And what about privacy? That seems huge.
It is huge and critical. Not all data is useful, and you certainly can't just use any data you find. Protecting sensitive info is non-negotiable. That's where data anonymization comes in. It's about removing or encrypting anything that could identify a person PII, personally identifiable information, names, social security numbers, medical records. You strip that out or scramble it so you can analyze trends without violating privacy.
Okay, anonymization for private data. What about open data? Can anyone just grab that and run with it?
Well, open data means it should be freely accessible, usable, and distributable by anyone. But there are criteria. The public needs access, people need the right to reuse and redistribute it, and it should be available to everyone without discrimination. It's about transparency and fostering innovation.
So beyond privacy and openness, what practical things does an analyst think about when choosing data for a project?
Several key things. How will we collect it? Internal systems. Buying external data. Surveys. Where does it come from? Is it first party, our own data, second party from a partner, or third party bought from an aggregator? This affects trust and relevance. What specific data types do we actually need? Don't collect extra noise. How much data? Is a sample enough, or do we need the whole data set? Statistical significance matters. And how much time do we have? If it's urgent, using existing clean data might be the only option.
And data comes in different formats, right? What are the common ones, and why does that matter?
Yeah, lots of formats. The big split analysts often deal with is structured data versus unstructured data. Structured data fits nicely into databases, rows, columns like sales records. Easy to analyze. Unstructured data is messier, customer emails, social media comments, videos, sensor logs. Harder to analyze, but often full of rich insights like customer feelings or hidden trends. You also have qualitative versus quantitative, continuous versus discrete. Knowing the format tells you how you can analyze it. And because data comes in all these forms, you often need data transformation. That's converting data from one format or structure to another. It involves things like copying data, deleting junk, standardizing terms like USA versus United States, joining tables together, or changing file types like Excel to CSV.
Why go through all that trouble? What are the business reasons for transforming data?
Several key reasons. To make it easier to use across different teams, to make it compatible with different software systems. Sometimes you need to structure it specifically to move it between systems, like from operations to a data warehouse. You often merge data from different places for a complete picture for decision-making, and you structure it so you can enhance it or compare it accurately with other data.
And then there's the term big data. We hear it all the time. What makes data big data versus just a lot of data?
Right. Big data isn't just large. It refers to data sets that are so enormous, growing so fast, and so complex that traditional tools just can't handle them. The classic definition uses the 3 V's. Volume. The sheer scale of data, we're talking petabytes, zettabytes, needs things like cloud storage. Velocity. The speed at which data is generated and needs processing, often real-time. Think fraud detection, stock feeds. Variety. Data coming from many different sources, both structured and unstructured. Social media, sensors, logs, transactions. Integrating it all is the challenge and the opportunity.
Okay, fascinating. Let's wrap up by looking ahead. How are cutting-edge technologies like Python, IoT, and AI changing data analytics?
Python's become huge in data analysis. It's relatively easy to learn, handles big, complex data sets well. It has amazing libraries, pandas for manipulating data, NumPy for math, scikit-learn for machine learning. These let analysts do really advanced modeling, not just basic queries. You can build custom models, websites, test software, build AI, plus great graphics support. And now, you can even use Python right inside Excel, which is pretty cool.
And the Internet of Things, IoT, all those connected devices?
Yeah, IoT is just generating an explosion of data. Smart factories, smart cities, wearables, all sending constant streams of information. Data analytics is absolutely essential to make any sense of that flood for things like predictive maintenance, knowing a machine will fail before it does, optimizing operations in real time. It unlocks the value in all that connected device data.
And finally, artificial intelligence. How is AI impacting analytics?
AI is really taking analytics to the next level. It improves existing analytics by finding super complex patterns humans might miss. It dramatically improves things like preventative maintenance, predicting failures really accurately, saving tons on downtime and costs. It enhances customer service by analyzing interactions to personalize support. And by monitoring things like social media, AI can generate highly targeted recommendations, creating personalized experiences at a massive scale. It's shifting analysis from reactive to proactive and often automated.
Wow. Well, that was an incredibly thorough deep dive into data analytics, drawing from Connect Master Management Information Systems. Thanks so much for walking us through that. And thank you, our listeners, especially you future business leaders, for joining us.
My pleasure. And as you think about all this, the power to predict, to optimize, here's something to consider. What's one specific business challenge or decision in the field you're interested in, marketing, finance, whatever, that you think could be totally transformed by predictive analytics?
Yeah.
And why that one? We'd genuinely love to hear your ideas.
That is a great question to chew on. Definitely let us know your thoughts. And please remember to like, subscribe, follow, share this with friends or colleagues, and comment. Stay updated on all our deep dives and keep the conversation going. We really look forward to hearing from you.